Good morning, everybody. Welcome to this lovely Friday morning's webinar on two-wire technology. I want to welcome you guys out and let you guys know that you're in for a little treat with our friend Chris Wright over at Baseline. He's going to be presenting some great information on two-wire technology and a little bit about all of that. Technologies have definitely come a long way in regards to controllers and the conventional controller method, but this two-wire technology is definitely something that's really cool and really interesting. So I'm not going to waste too much more time. I want to turn it over to Chris. I want to remind you guys to ask any questions that you might have in the Q&A box down there in the lower right corner. And if you guys want to chat amongst yourselves, feel free to over in the lower right hand corner in the chat box. So without further ado, Chris, take it away.
Very good. Thank you, Jake, and I appreciate the opportunity to present today on two-wire technology. It's a technology that is quickly overtaking the irrigation controls market and is really becoming the standard for irrigation controls in design, implementation, and maintenance of irrigation systems. So what I want to discuss today is, as a designer, how can you harness the power of two-wire and utilize many of the advanced features of that technology in streamlining your design process and making sure that you are providing the performance capabilities of an irrigation control system that your clients would expect long term. So as we look at two-wire and define what two-wire is, I would hope that most of you have had some exposure to two-wire at this point, but two-wire is literally just two wires. And rather than having a conventional system where you have a hot wire and a common wire running from each of the irrigation control valves back to the controller, you have in place a two-wire path with decoder devices that then interface with those valves to perform irrigation functions. So it's a much more streamlined configuration or design that allows the system to operate while minimizing many of the materials that may normally be required with a conventional wire system. So there's a number of advantages to two-wire, one being lower material cost, especially on larger systems. It's very scalable because you can increase the system size by splicing into an existing wire without having to run additional wire back controller location. Makes it very easy to repair from a maintenance perspective. If a power company goes through the main line and cuts all of the irrigation wire, the maintenance contractor merely needs to splice two wires back together rather than trying to tone out and splice together multiple wires that can take many hours to do. There's lower labor costs associated with two-wire, both in installation and maintenance, which saves labor hours. And in reality, it's just a greener implementation in that it's less copper in the ground with a lower impact to the environment. But the most important thing is that two-wire is much smarter than conventional wire, and using the technology we can make better irrigation decisions based on the technology and the information that can be retrieved from the field or from the irrigation system when making irrigation decisions. Pictures speak louder than words. So these two pictures illustrate beautifully the first 4 or 5 advantages of two wire, where we've got on the left a splice box that is a rat's nest of wire and connections where there are many points of potential failure in that wire field, compared to a two-wire installation on the right, where there is far less wire, far fewer splices in that wire, and the interface with a decoder device that performs the functions of the irrigation system. One of the distinct advantages of two-wire is that you can extend the wire length limits of the wire field to operate irrigation control valves. From a new design perspective, that means that you can have much larger wire fields with fewer controllers, and depending on the two-wire manufacturer, these wire length runs can exceed even a mile's worth of wire or more, where you can have a single length run of 5,000 feet going in both directions from the controller, or you can have a loop of 10,000 feet or more depending on the wire gauge that's being used. So it allows, again, much larger systems with fewer controllers, which means fewer hardware components that are required, which ultimately will reduce material costs on the project. Of the manufacturer of two-wire components, there's really 5 basic requirements that are required for two-wire specification. First and foremost is the wire type. Most two-wire manufacturers require double jacketed, double insulated, solid core copper wire that is durable enough to hold up to the rigors of the field during installation and maintenance long term, and will ensure the integrity of information that is traveling over that two-wire path from controller to decoder devices. One thing that I want to emphasize with the wire type is that there is a difference in the coatings of two-wire decoder cable versus standard conventional 14 gauge wire. And that is that the coating on standard conventional wire is PVC, and the coating on the wire in decoder cable is polyethylene. And polyethylene will hold up much better to the heat and demands of a two-wire system versus PVC coated wire, and will greatly eliminate the chances of cracking and pinholes that could affect that wire and impact the communication of controller to decoder devices. Wire connections are also very important in a two-wire system, again, regardless of the manufacturer. Waterproof connections are required on all two-wire connections to ensure that those connections stay robust and clean and uncorroded by water that may have an effect on that over the long term. Typically, a DBR Y6 or equivalent connector is suitable for two-wire connections to maintain the integrity of those communications. Wire length limits vary by manufacturer, but you do have the ability to run much longer wire length runs than conventional wire. Most manufacturers will have a device limit for the number of decoders that can be installed on the wire path at different wire lengths that need to be considered when doing design work and designing a two-wire system. And surge protection is paramount in a 2-wire system, because you've got rather expensive decoder devices that are in ground out in the field that can be destroyed by surges or lightning strikes that can be very costly to replace, and will also affect the performance and or the functionality of the irrigation system. So keep those 5 things in mind when doing design work for 2-wire systems, and make sure to consult the manufacturer of the product that you're designing with to make sure that you meet their specifications. There's many different kinds of 2-wire devices that are ancillary components to the control system that perform the functions of the controller. There are smart sensors that can contribute to conservation objectives. There's 2-wire decoders for system operation that interface with different components, whether they be valves or pumps or switches. There's some manufacturers that provide a conventional wire retrofit for 2-wire, which I'll go into in a moment. And then there's also 2-wire ready smart flow management and flow monitoring devices in the form of flow sensors and or hydrometers. The types of decoders vary, and they will vary by manufacturer as well. Everybody provides, of course, valve decoders that interface with the irrigation control valves. Master valve decoders that will interface with the master valve on the system, pump start decoders, flow decoders, event decoders, and smart sensors. As it relates to baseline, our soil moisture sensors are in fact a decoder device. When dealing with decoders, it's different configuration than with conventional wire, because decoders come in different shapes and sizes. So baseline manufactures decoders in a 1, 2, and 4 station configuration, and since a decoder has the ability to run or operate multiple control zone valves, the decoder itself needs to have a serial number sequence associated with it, so the controller knows which valve it is actually interfacing with. So if we take, for example, this 4-station decoder, it has a unique serial number that's associated with it, 7601, which is printed on the decoder itself. Now, because this decoder can operate 4 zones, there are 3 other serial numbers that are embedded in that decoder that would be associated with other control zone valves, those being 7602, 7603, and 7604. Baseline color codes the output wires from the decoder and follows this same number sequence through its serial numbers to make it easy for the installation contractor to identify which zone is associated with which wire in the field, and then can use that information in the configuration and programming of the controller. When we're looking at a existing site that we want to upgrade to 2-wire technology, there are available retrofit powered decoders which will accommodate that existing conventional wire. So in this case, I have a terminal board with 24 posts available to accommodate conventional wire, but in reality, this is a decoder that is broken into 2 12-station decoder sections. So posts 1 through 12 is one 12-station decoder, posts 13 through 24 are another 12-station decoder, and then that powered decoder also has available 2-wire posts that can be used to add other components to the system on a 2-wire path. The advantage to a powered decoder is that it can be used to retrofit an existing site utilizing a lot of the existing wire infrastructure, and then you have the programming and diagnostic power of 2-wire operating over that conventional wire. So to help illustrate that process, if I have a site, for example, where I have more than one controller on that site, and I can get a 2-wire path between those controller locations, I can consolidate multiple controllers into a single interface. So on the left, I have a controller with an interface for programming, and inside the cabinet there is a powered decoder board installed with the valve wires from the pre-existing controller feeding into that cabinet, wired up to that powered decoder. On the second controller, again in a location where I can get a wire path between them, I have a cabinet with powered decoders installed inside, accommodating the existing valve wires running out to the field, and then I connect those two controllers together with a 2-wire path, and now have effectively turned two 24-station controllers into one 48-station controller with one interface. So to illustrate it in a different way, as it would look on a site, if I had a site with 3 controllers and I was able to get a wire path between 2 controller locations, I could then use a controller with an interface and a powered decoder connected to that controller with the interface and consolidate them into a single controller. This gives a real-world example where this process was executed. Park site in Las Vegas, Nevada, where it was an existing Maxicom site that had a CCU and 4 satellite controllers installed, all in a bank right next to each other. We went in and replaced the CCU with a base station controller, and then in each one of the satellite controllers, the faceplates were removed, the control boards were removed from the Maxicom system, and powered decoders were laid into those pedestals. The existing valve wire was all wired up to those terminal posts, and then the wire that linked them together was the existing PE89 cable that ran from pedestal to pedestal back to the CCU. We used that as a wire path to consolidate all 4 of those controllers into one interface. So now that one controller operates 176 zones on this one park site. So there's some advantages to that, in that it allows for fewer communication modules, which means less hardware cost, and if we're connected to central control, it could result in fewer data service fees or subscription fees associated with each one of those controllers also.
Hey, Chris.
Yes, sir.
Hey, I wanted to jump in real quick. We had a question that really pertained to that one from Tamra. She really is asking, wouldn't it be cheaper to take out the old 2-wire system to a new decoder rather than using the power bicoder? Because you still have to lay all the new wire, right? Can you explain that, maybe what the difference would be there?
Okay, so there was no new wire that was required for this retrofit. So all of the wires that are shown here attached to this powered decoder are the existing or pre-existing valve control wires. So They were run into the pedestals through the sweeps coming up into the PED. This powered decoder was just laid into that existing pedestal, powered off of the transformer that was pre-existing in the bottom of the pedestal, and no additional or new wire was required to be installed either in the landscape or at the controller locations. So with these powered decoders, you're typically looking at a cost of about $300 per 12 stations of conventional wire. So for roughly $600, we were able to use these decoder devices to operate that existing conventional wire, which saved a lot of labor, installation cost, and other material cost. So in reality, on this site, we rented about $65,000 worth of Rainbird equipment for less than $10,000 to bring it up to the latest technology. Does that answer the question?
Yeah, I think that does it. Thank you. Keep going.
Okay. So when we're dealing with a retrofit situation with conventional wire, like a in-field 2-wire decoder that has a unique serial number associated with it, each one of the posts that the conventional wire is connected to also has a unique serial number associated with it, and those serial numbers are used in the configuration in the program controller. So again, it gives us the ability to configure a site and program a pre-existing site that was conventional wire with 2-wire methodologies and performance capabilities. Now there's some distinct advantages to smart decoders, and by that I mean that not all 2-wire is the same, and there are a number of 2-wire manufacturers that provide decoders that interface with valves to perform function, but there are also smart decoders that are available that are far more powerful than a standard decoder. And those smart decoders will allow any combination of 2-wire or conventional wire. They provide two-way advanced digital communication, which really enhances the performance of the irrigation system. And because of that two-way advanced communication, it can simplify the programming in that the devices are addressed from the controller, or they can be changed from the controller, so that it makes it easy for the contractor to set the system up. So we're going to focus really on two-way advanced digital communication and the advantages of that as it relates to a 2-wire system. So when I say two-way communication to all devices, that means that I can send a command from the controller to devices in the field to perform a function, but I can also retrieve information from devices in the field and bring that information back to the controller for diagnostic purposes or to make irrigation decisions. And having the ability to have true two-way communication to all devices connected to the wire field can greatly enhance the capabilities of the 2-wire controller. One of the maintenance advantages to two-way communication is that feedback from decoder devices can report the electrical health and functionality of components connected to them. So we can get a status of a solenoid, we can get the condition of a switch that may be operating a component on the irrigation system, and we can also get sensor status, whether it's a flow sensor or a moisture sensor or a temperature sensor. And that information, diagnostic information, comes back into the controller and is viewable by the user to monitor an irrigation system. This two-way communication also gives us the ability to receive real-time measurement from sensors, whether it be a soil moisture sensor or a flow sensor. And this real-time information can be used to make better irrigation decisions, which will ultimately result in real conservation. So with a baseline system, for example, when soil moisture sensor decoders are installed in the field and connected to the wire field, sensor readings are made every 10 minutes when the system is idle and every 3 minutes when the system is operating. And that real-time information can be used to make better irrigation decisions as to how much water is being applied to the landscape and whether the accurate or adequate amount of water has been applied that could result in conservation. So a real life example of where this technology was utilized to measure real-time moisture content after irrigation applications was a site in Utah in August of 2015 where this controller was scheduled to water every other day, and the sensor decoder was providing feedback to the controller during operation to regulate how much water needed to be applied in order to maintain a desired moisture level content in that soil profile, in this case of 27%. So on this site, the controller operated 12 of 15 scheduled days. In August, in this region, the historical ET value is 7.4 inches of plant water requirement. We were irrigating 2,500 square feet of turf in this zone. The plant water requirement at a 65% distribution uniformity was 13,500 gallons. We actually applied only 8,400 gallons, which translated to a 38% savings. So again, it's having the ability to have two-way communication to decoder devices and use that information as it's coming to us in real time to make better irrigation decisions. This can also relate to flow and flow sensing. With the ability to have two-way communication to flow decoders, it gives us the ability to read flow values every 30 seconds during the operation of the controller and have that value displayed on the controller itself. The controller then uses those flow values to monitor for variances of learned flow and to manage concurrent operation of zones based on the design gallons per minute. And with that two-way communication, it can allow us to manage complex hydraulics that may exist on a particular site or project. So because of two-wire, base station 3200 controller can support up to 8 points of connection, and a point of connection being a master valve and a flow sensor. And those master valves and flow sensors can be configured in the two-wire programming capabilities to be associated with different water sources that can help us manage pulling from traditional potable sources or pulling from secondary sources such as pressurized irrigation, wells, pumps, or cisterns. Now, because these different components are sharing information to the controller over that two-wire path and reporting real-time flow values, it can also help us to optimize shared water sources. So using the two-wire technology, we can ultimately have up to 30 controllers that are sharing 20 points of connection, and we can have up to 20 shared main lines assigned to those 20 points of connection. So in reality and at scale, if the math is done, it gives us the ability, because of the two-wire technology, to manage the operation of up to 6,000 valves at one time. The two-wire also gives us the ability to start, stop, or pause programs depending on the condition of a decoder device that we are interfacing with. So we can use a event decoder to interface with any dry contact switch device to open or close that switch based on a start, stop, or pause condition. We can also use a moisture sensor with the built-in decoder to start, stop, or pause a program based on a upper or lower limit that moisture sensor is recording. And that can be a sensor installed in the landscape, or it could be a sensor installed in a cistern as a level indicator. We can also use a temperature sensor attached to a decoder to start, stop, or pause a program based on air temperature conditions. So in this case, on the far left, we're interfacing with a event decoder, and we want to start a program when the switch equals an open condition. In the middle, we're using a moisture sensor to start a program when the moisture reading equals 26%. And on the far right, we're using a temperature sensor to start a program when the temperature is below 34 degrees Fahrenheit. So each one of these sensors can be configured for a specific program or for all programs to start, stop, or pause a program from operating based on the information that we're receiving from those decoder devices over the two-wire path back to the controller. So in summary, two-wire simplifies the design and installation and maintenance of irrigation systems. The system performance is enhanced by the capabilities of the two-wire because we're interfacing with smart decoders that are providing feedback to the controller to help make better irrigation decisions and give us diagnostic information to maintain the system. It also goes beyond just the normal functionality of the irrigation system and allows us to handle complex hydraulics and water sources that are becoming more and more prevalent on sites today. And it also allows us to integrate other site components that may or may not be associated with the irrigation system that are operating as a switch device. And that can be programmed from the irrigation controller as well. So with the two-wire technology, it is a step above conventional wire, though there's expensive components that do go into the ground to interface with these devices. On a large system, it becomes far more economical because of the decreased amount of conventional wire that is required in the ground to perform those same functions. So with that, I thank you for your attention. I hope that it was useful information, and I will now address any questions if there are any.
Yeah, we did get a couple questions. We'll just take these one at a time. The first one, and this is sort of a general statement overall, but is there, based on at least your experience, is there a break-even number of zones that make a two-wire system more economical versus a traditional system? So I know there's a lot more that go into it than just how many zones there are, but if you have any, other comments on that.
Right.
Good.
Yeah. A lot of that is dependent on the current cost of copper, which can be volatile and fluctuate quite a bit over a short period of time. And the other consideration is the cost of the decoders that you're using from any given manufacturer. In a baseline system, typically it's 40 zones or more, where two-wire becomes more economical than conventional wire.
Great. The next one we have from Tyson is, are there any flow sensors or master valves that are not compatible with baseline?
Okay, that's a good question. So the flow decoders that baseline engineers and provides will receive or read the pulse output from any flow sensor. So as long as we're getting a pulse output, we can interface with it and use it on a baseline system. Now I will say that the baseline branded flow sensors that we provide, the plastic flow sensor, for example, is sourced from Creative Sensor Technologies, and we make it two-wire ready, meaning that we pot it with a decoder, and it makes it two-wire ready, so that when it's installed on the two-wire path and we search for the decoder, it recognizes the size of the flow sensor that decoder is embedded in, and will automatically set the K value in the offset. So it makes it literally plug and play. Same is true for the hydrometers, which we source from Netafim and make them two-wire ready. Same process. It'll recognize the size of the hydrometer and automatically set the pulses per gallon for that device. But we can interface with, any pre-existing flow sensor or other brands as long as they provide a pulse output.
All right, and I was a little bit informed that apparently Hunter might have a proprietary output on their flow clicks. Is that probably accurate? Because it's not the same thing, right?
Correct. Yes, we are not able to interface with the Hunter flow click.
There you go. Okay. So that was all the questions that we had. If you guys have any other questions for Chris at any time, definitely give us an email. We can shoot it over, or send him something directly, I guess is okay. I guess you need to figure out where you are within the same region, but definitely get it over to us and we can shoot it over and answer whatever you guys have. Is there anything else you have, Chris?
No, I just appreciate the opportunity, and if anybody needs more information, the baseline website is a very comprehensive resource for two-wire specification, installation details, everything that a designer would need for an irrigation design using our technology.
Great. Well, thank you guys for attending, and we will talk to you again. Have a good weekend.
Thank you very much.